Bijisha Sodari, and today I'll be presenting my technical report on wireless sensor network routing optimization. This is the project I did for the data structure and algorithms, and honestly, it was the most interesting topics I had worked so far. So, yeah, my main focus in this report was on how to make data transmission in sensor networks more energy efficient, more reliable, and overall smarter by using different data structures and algorithms that we studied in DSA. Before I get into it, I just want to take second thank to my teacher for giving me this opportunity. Um, yeah, and online resources and references was also super helpful in this completing in this project. um, all right, so just to summarize what the report is about. Wireless sensor network, or WSNS, are used in so many modern areas like environmental monitoring, healthcare, industrial automations, smart cities, and so on. These networks have hundreds of tiny devices called sensor nodes. They collect data, send it around, and finally deliver it into a central station, kind of like how our body nerves send signals to the brain. But the main challenge is its sensor runs on a limited battery, and once it dies, part of the network goes down. So the goal is to design a routing system that keeps communications efficient but uses the least energy possible. To solve that, I created a routing optimization reports that combines clustering, energy aware, and energy aware selections, and uh, shortest path algorithms. It basically finds smart routes and saves energy and still sends all data reliably. So yeah, let's start with introduction. Wireless sensor networks, or WSNs, are these systems which made up of a lot of small nodes, each with their own sensors, processors, and its tiny transmitter. They call it informations like temperature, humidity, pressure, you name it, and send it to a base station. But they have serious energy limitation, since they usually work on batteries and rare places in remote places. um, so to keep the system alive for a long time, we need a routing algorithm that uses energy carefully, avoids unnecessary data transfers, and still delivers everything properly. The main goals of my project were: first, to reduce energy consumptions so nodes don't die quickly. Second, to improve packet delivery packet delivery, meaning fewer lost messages. Third, to use clustering to group nearby nodes together so they don't all communicate separately. And finally, to apply this sector algorithm to find the most efficient paths based on energy, cost, and distance. All of these were tested through simulations, and I evaluated things like time complexity, space complexity, and energy efficiency. And now, let's move on to the theory part. Everything in this project relies heavily on the use of data structures and algorithm from DSA. So in this system, I used graphs to represent how nodes are connected, spanning trees, and MST, minimum spanning tree, to minimize total energy in connection, priority queues to help these Chetra's algorithm pick the next best node efficiently, merge to organize nodes, or cluster hands cluster head by energy level or distance. And finally, Dijkstra's algorithm to calculate the shortest and most energy efficient paths. Basically, all this works together: graphs for structures, queries for selection, sortings for organization, and Dijkstra's for smart routing. So graphs were used to model the smart sensors network. Used to model the sensor network. Each node is a vertex, and the connection between them is a edge with a weight that represents the energy, cost, or distance. Then I applied a minimum spanning tree MST algorithm like prims and crystals to make sure every node stays connected with the least possible total energy. This helps reduce the redundant transmission of saves energy across the network. It's like finding the shortest set of routes that connect all the cities without wasting any extra distance. So now the next data structures used were priority queues and merge sort. So the priority queue helped in routing by always picking the node with the lowest energy and energy cost first, which is a super important in Dijkstra's algorithm. It is basically like saying let's send data through its easiest path first, and merge sort was used to order, not based on parameters like distance or remain energy. So since merge sort has a time complexity of O and log n is stable, it's perfect for sorting big data sets in a predictable way. So yeah, it helped organize everything nicely before routing started. So now coming to this sector's algorithm, which is the brain of the whole routing process. It works like a GPS systems, always finding the shortest path between the source and the destinations. But in my project, instead of just physical distance, I also considered energy cost. So the shortest path mean the most energy efficient route, not just the closest one. For example, if node is near but has low battery, Dijkstra's algorithm skips it and choose another with more power, balancing energies and distance both. This really helped extend the nature networks lifetime and maintain communication reliability. So alright, moving to the implementation section. So I coded the simulation in Python using data structures like lists, dictionaries, and classes to model nodes and energy levels. Is not set its ID, coordinates, energy, and cluster ID. Cluster heads were selected probabilistically, similar to the least protocol. Then data was sent to the cluster heads, and from there the shortest path was calculated using Dijkstra's algorithm. So if a node or cluster head failed, the system automatically selected another node with enough energy to take over, ensuring there was no data loss. So now let's talk about the performance evaluation. Analyze the algorithm, time complexity, space complexity, and energy efficiency. Cluster head selection took O and N. Cluster assignment was O N into C. And then routing computations using Dijkstra's were about O C square, and failure handling was O C into M. And for space complexity, storing all the nodes and routing tables took around O n plus C square space. Basically, as the number of nodes increased, time and memory uses also went up, but the performance stayed stable. According to my simulation, the proposed routing algorithm performed better than traditional ones like AODV and Leech. It consumed the least energy, had a higher packet delivery ratio, and network lifetime was noticeably longer. Even even when some nodes failed, the algorithm managed to reroute data efficiently. So overall, this approach achieved both better reliability and better energy distribution. It showed that data structures, when used smartly, can make a huge difference in network performance. So to wrap it up, my project showed the combining data structures like graph, quiz, sorting, and algorithms like MST and these structures can create a powerful, energy efficient routing system of wireless sensor networks. The proposal method improve time efficiency, reduce energy waste, and increase the network's lifetime. In the future, I do like to include machine learning techniques to predict which nodes might fail soon and adapt routing automatically. Also, adding energy harvesting like using solar power nodes could make it even more sustainable. So, yeah, this project really helped me see how data structure algorithm works together in real world systems. Here are the reference I use mainly works by um, Kruskal, Prim, these sectors, and others, as well as online resources from Geeks for Geeks and tutorials points, and helped a lot in understanding implementation details. Thank you so much for listening. Um, and that's it. I want to end it.